Natarajan, and today I would like to start my first screen sharing, screencasting experience by trying to going through something called as database driven development. So normally, if most people are when they're trying to develop an app, let us say a web app. So if it's going to be a new app, they right away start with Rails new, the app name command, and then they start with models and then the controllers actually, and then even worse than that is the scaffold, which generates the routes, models, and everything, right? Uh, but I last year I read a book called Mastering PostgreSQL by Dimitri Fontaine. He explains PostgreSQL's features and how to write queries and how to use PostgreSQL's advanced features targeted specifically towards application developers like me. So there I saw a lot of new things that blew my mind. One of the concept that he was proposing was, I mean, he was doing it in the book was uh, when he was about to design an app, he started with the database design and he just opened a text file and then he's just designing the database first and then the tables and then the constraints and then immediately he gets to the business use cases where he's uh, imagining the foreshadowing, he's imagining situations like in what are all different ways the data can be accessed, and then he starts to write SQL, select queries and then update queries and then even insert queries, uh, so that he's like optimizing it for performance and just the right amount of code to get you the exact data. Nothing blown too much, nothing like extra. I'm a very bad communicator. You might have seen it. So it's great. This is just the first screencast. I will improve. I'm kind of like nervous, even though there's nobody around here. I'm just sitting in a room staring at a wall. I just need to get comfortable before this screaming Mac. Okay, so I have a problem. I came across this yesterday. This is an interview problem, I suppose. So the problem is about an employee management app where you have company's employees and they all have different roles. Like a role can be a boss, a manager, a lead, and engineer. It can be any number of these things. Let us just constrain it to four, and there is a hierarchy if you notice it. So a boss will not have anybody superior to him, and similarly an engineer will not have anybody reporting to him. So we have this kind of linear hierarchy. Forget about Facebook's open office and startups open culture, like flat hierarchy. Forget about that. Here we are just designing an age old system. So what we have here is a linear system where any employee is going to have many people report to him. One or more people report to him, so they, let's call them reportees. And then each employee will be reporting to one specific manager, just one manager. He won't report to multiple managers. So for example, an engineer will report to a lead and the lead will report to a single manager, and all managers in the company will report to the boss. And similarly, the lead can have many engineers and manager can have many leads. So it is just there are no like bypassing, like an engineer cannot directly report to manager, although an engineer can see the hierarchy of the bosses. Like he can see his lead and then his boss, and then going all the way up to the uh, final CEO. So here's the task. The task, okay, so you can also see here, boss doesn't report to anybody apart from boss. Yeah, what I said. So the task is to create a REST. Forget about REST endpoint. We're not doing REST. We're not doing web part of the thing. We're just doing database design here. So the scenario would be something like, given an employee's name or ID, you should be able to get his reportees. Like it will be an array of employees that report to him. So that is what we have here. So let us see. X, if X is an employee, then X dot reporter should give X's boss, immediate boss, and then X dot reporters will give a uh, list of his teammates that they are reporting to him. And then we also can have x dot superiors and x dot subordinates. Like uh, reporter and reportees just give you immediate link above or below. Superiors will give all the way up till the top, and subordinates will give all the way till the bottom. So if we call boss dot subordinates, all of the employees will be listed. And similarly, if you take a lowest level employee, the engineer, and then if you say engineer dot, and don't ask me about why the engineer is lowest level. um, let's just think that they get the job, actual job done. So, and the engineers don't care about this hierarchy. Let's only care about money. Okay. So don't bother that. In the food chain, is it the food chain? We're at the bottom. We'll have our time. Let's wait. Okay. Yeah, that was a burp. I had some thick milk. Okay. So this is the design. Like if since I'm a Rails developer, I think in this term. So I'm thinking like X dot reporter should give a single data, and reportee should give an array of data and these things. And then like CEO will not have a reporter to him. CEO dot reporter dot nil should be true. Something like that. And what are all these things? So all roles except the CEO will have some kind of reporter, one reporter person to them, and all reportees. I mean, an engineer. What is it? SD? No, SD is just the engineer. Engineer will have no reportees to them. So engineer will only report to a manager. So similarly, all roles, all employees except the engineers. SD is engineer. I'll correct it. So all roles except the engineer, all employees except engineers will have reportees present to them, reporting to them. So this can be a sample data set. So there's a boss role, and his name is Boss Joe, and then there's Manager Joe, and then Lead Joe, and then Engineer Joe. And this is his salary, their salary 120, 40, 30, 10. And what is this? This is the percentage. Like if you were to list all of their salaries, and if you just add up them, let us say 120 plus 70, 80, so 200. It total adds up to 200, right? Uh, so what percentage of that total salary is the boss's salary? 120 by 60 into 100 is 60 percentage. So similarly, 20 percentage, 15, 5 for the engineer, 5 percentage for the engineer. Don't worry, guys. We will do. We will proceed. What's that? Persist. Okay. Now, so in this video, I'm going to show the database design first. How to go about designing this thing using the database driven development approach. That's a mouthful. So here's the problem for us. Okay, just something that I showed you right now. So let's not. And here we have this thing. So this is a SQL file, and so before that I had created a database called createDB employee underscore STA. I thought it is a single table inheritance. I still don't know if it is a single table inheritance. I don't think it is a single table inheritance, because I think you need to have multiple classes in Rails for that to be. But even though we have an alias for classes for the same class here, we'll get to that in the next video. So forget about the database name. It is just employee underscore STE. And then after creating it, you can put all the queries related to that database in this file, and then all you have to do every single time is just feed that file into this database and then pass it to the SQL command, and then it will just execute it. See, very beautiful. So every single time I'm dropping the table, I'm creating it, I'm inserting the records, and then I'm doing all of these select queries, and then even deletes, and every single time it runs the whole thing, and it is very fast. Imagine doing this thing with Rails. Rails is rec db migrate, create db, drop, migrate. It would take a lot of time, but here it's just the speed of pressing enter. You get everything. Okay, so you see all the creates. Now let us go. The first task is to create the actual table. So here we are only bothered about one table, employees, and so we're creating it. And as usual, the ID is an auto increment primary key, and then we have name, uh, and then role, and then salary, and then reporter ID. Reporter ID is the foreign key on the same table, so we're not we can't define it as a foreign key here. And then role, we are putting a database level constraint that it can be only any one of these four. It can be either bossman or manager, lead or inch, and not null. So you should pause it. So while designing this, like everything else would seem like obvious, the id, name, role, and even the check constraints would seem obvious to you, but um, when you're writing the actual create query, that is when you would realize the importance of the not nulls. Normally in Rails we might skip those things, and then this would come to bite us later on during the development phase. So this is a nice place to catch that kind of bug. And then you also get to see the data type, and you can cross check with the actual documentation to see if the size they take is what something that you need. For example, when I searched for this salary, I think there was this tiny int and int. Tiny int was, it had a very small range, like up to 32,000 something only. So I think salary can be more, so I didn't resort for that. So you kind of get to see that and make proper decision here. In Rails it is there, but in my experience most people don't pay attention to that, like especially the young developers, juniors. They just do t dot string, t dot int, t dot float if they fancy that, and that's it. They don't bother about the precision, the scale, and then they don't bother looking up the corresponding data types that match with the Rails data type to the actual Postgres database, and what their implications would be. So and then it is always confusing, that limit option that we have in the Rails migration. So we have that limit, right? So most people don't know what it does. I had to look it up every single time. So it is better to do it at database level and see. Okay. And then we have these inserts just for the dummy data. And I'm just doing insert every single line, every single data. I mean, I'm inserting one row at a time. But you can also insert the whole thing in uh, one insert, like there is batch insert that is called as, it's just one query where you just separate this values in a comma separated params. Uh, but I had to resort to this thing. I need to look up the ID, right? So after I insert the boss, I had to take his ID and then pass it to the subsequent rows. Similarly for other guys. So we have the minimal data set. So what we have is one boss, and then two managers who report to the boss, and then we have four leads who report to this. Two leads report to manager one, and two leads report to manager two, and then we have five engineers. Three of them report to lead one, and then two of them report to lead two. And you can see that lead three and lead four don't have any reportees as of yet. Okay, so there is the data insertion part, and if you feed this thing, let me, can I comment it? No. So if you feed this file to this database and then pass it as an argument to psql, it will run it against that database, and you can see that all the inserts happened. And then what I'm doing here, I'm just echoing the whole database, select star from employees. What is this thing, echo? I found a way to kind of like put us in Ruby. This is echo slash echo, and then what you can, whatever string you type, you don't even have to put semicolon at the end, and then it will just print the thing. And see, this is emoji actually, hand points down. Vim doesn't display it properly here, I don't know why, it's irritating. um, but you can see it here. So all employees, I'm just displaying all employees, and there is select star from employees. So you are seeing it here, the whole database, I mean the whole table. We have one boss and his role and his salary. This is null. This small tiny square that you see is a representation of null. So by default, psql doesn't display anything for null. It doesn't say null, it just leaves it blank, which is very hard to make sense of. So I found some setting, I mean actually Dimitri set some setting to replace that with this. So this means null. So boss doesn't have a reporter ID. And then you have these managers whose reporters are boss's ID 1, and likewise. So you have 12 rows. And then let's go to the actual fun part. The going to the business case. Like, so this is the case where it is most, let us assume that this application, employee lookup application, is for the HR department, where HR software, where they need to look up the employee details and occasionally update them as well. So mostly it is just lookup. So for example, they want to see a person X, uh, like for example, engineer 5 Joe. They want to see who he reports to, his immediate manager. They want to see. So how would you go about doing that? So this is how you do it. So this thing with this this whole thing is a single query. You can see the semicolon only at the very end. So this whole thing is a single query, but it actually using this common table expression. This with expression is called as common table expression. Using this thing, you can see that you can nest a query within that. So uh, this is kind of like a variable where the inner query within this bracket, the result of that is assigned to this reportee variable. That is the temporary table, actually, not a variable. I'm speaking the programmer's language, but in database it is actually, where am I? Yeah, in database it is actually a temporary table. It runs this query, takes the data and puts it in a temporary table and calls it as reporter, and then we can use that in the query outside this thing. So this is the table. So we are taking lead. This is the guy who we need to find his reporter, right? So we take his row, and then all we do is just select everything, and then if you go to the result, you will see. So here it is, reporter of engineer 5 Joe. That is what we want, right? So reporter of, here it is, reporter of engineer 5 Joe. Yeah, reporter of engineer 5 Joe. So I've kind of formatted the display. So the reportee is engineer 5 Joe. His role is engineer. His reporter is lead 2 Joe. You can see it here. Engineer 5 reports to number 5. That is lead 2 Joe. You can see it here. So that is how this query is run. So all you have to do is you need to find the employee whose reporter ID is the same as this guy. And similarly, you can get a list of reportees, like given a manager name like lead 1 Joe. So some people, some X number of people report to him. So we need to find all of their names. So that is what we do. First we take the leads record and save it in the temporary table, so that we can get. So you can do these things in a subquery as well. But I find this thing more readable and much better. So what you do? So you take this lead, and then you're getting all the employees whose reporter ID is equal to the lead's ID. Very simple, as simple as that. The above one, the reporter query, is just the ulta of that. E dot ID is equal to R dot reporter ID, and E dot reporter ID is this thing. If you just spend some time, you'll kind of like make sense of it, right? So these are the simple use cases. Like you get the reporter of X, and then you get reportees of X. So you can see it here. So lead 1 Joe's reportees, lead 1, who is lead 1? 4. So who are all reporting to 4? So you can see 3 guys, engineer 1, 2, 3. Can we scroll down? Yes, here it is. So engineering lead 1 has these reportees, engineering 1, 2, 3, these 3 Joes. Okay. And then we have the fun part, the superiors of X and subordinates of X. So this is just not one level of up or down. It is just all the way through to the top or all the way to the bottom. So how would you do it? Here's where we get to use this nice feature of postgresql. It is using recursive to do this SQL. To do this common table expression. So the question is, find all superiors of engineering 5 Joe. Engineer 5 Joe. So engineer 5 Joe's superior, who are all? So he reports to this guy 5, lead 2 Joe. So the superior, first superior is lead 2, and then lead 2 superior is 2, manager 1 Joe is managed. So lead 2 and then manager 1, and then he reports to this guy boss Joe. So we need to return all these 3 as the answer for this question. So how do you do that? That is the fun part, right? So first So, so this is kind of like, and if you're doing it in a programming way, you just, as a programmer, it is easy to think about this problem. So how would you go about doing this thing? You can't do it in one query. And so what you would do is, first you take engineer 5 Joe, his record, and then get his reporter ID, and then find the employee that matches that ID. So find his immediate boss, and then take his ID, and then find his immediate reporter, and then go all the way until you can't find any immediate reporter, right? So that means we have reached the boss. So while going up the ladder, you, whatever row you find, you just add it to an empty array, and then finally when you reach the boss where then there are no reporters, you just return the array that has accumulated the result. So that is exactly what this is doing. Even though this is a single query, the database would run the iterative loop inside, but still it is efficient because you are avoiding a lot of network calls. So you're not going to and fro between the Rails application to database to run all these queries for each and every lookup. So this is much faster still. So the way that it works is, um, for recursive CTE, recursive common table expression, this one, this with part. So all you have to do is uh, you have to union, like combine the results of two queries. And the first query always mentions the starting point. So the starting point is, we need to first look up engineer file's record, right? And then you union it with the recursive call to the same data set. So union means it removes duplicates, it combines and then removes duplicates. And make sure, you should make sure that uh, both the queries have the same set of columns. So select star, select star. Since we are doing it only through employees, I'm just putting it star. So but you need to make sure they are the same number of columns and of the same corresponding data types. So and then what you do is, you take this guy and then you select star from employees, and then you join it with superiors. Where is superiors? This guy again, recursive. We are in inside the recursive block, and then we are calling it. But actually, in PostgreSQL documentation, I saw that this is actually not recursive. This is kind of like iterative process. So what I mean by that is that if you do the same thing in Rails code, you won't write recursive. You would kind of like recursive code as well, but then it would be kind of like looping as well, iterating. So once we go to the next video, I will show you that part. So right now, all you have to know that you take this thing and then you join on this guy. That's it. So what happens is, every time the dataset grows, and this it operates on the same dataset. So it is like in Rails, Ruby enumerable, we have each with object, right? So every time you iterate over an enumerable, you can give it an initial object, empty object, like it can be an array or a hash, and then on each pass of the each iteration, this you can feed elements to this initial object that you gave, so that by the end of the whole loop, this object would have grown. So similarly, you're just combining dataset on top of dataset until you find that guy. So you're joining it, and then on reporter's id is equal to this guy's id. So you're finding um, first engineer Joe's reporter. So that's what you're finding, it s dot reporter id. So the way that it operates, it uses kind of like two temporary tables. So you have to go and see the official documentation to understand how it works. But then once you start using it, you will get the hang of it. So this is especially useful for solving this kind of hierarchical tree-like structures. So you don't have to worry like, how would I know when to use this thing? So as soon as you see the problem, you would know that this is it. So the word like hierarchy, like tree structure, uh, so, so, so those kind of problems, you can use this recursive CTEs. So now let us go and see. So superiors of X is superiors of engineering 5 Joe. So starting from engineering 5 Joe, you have his lead, and then lead two's lead is, reporter is manager, and then his reporter is boss one. So you go all the way like that. You can see it, right? So his reporter is 5, and then 5 comes here, and then 5 is 2, and then 2 comes here. 2's reporter ID is 1, and then 1 is the boss, and then he doesn't have. So we stop till we reach this null here. Okay, and then having done that, it is now easy to write subordinates of X as well. It is exactly the same. You just change the order of the lookup. So you just say instead of s dot report id equal to e dot id, you do s dot id equal to e dot report id. Nothing else changes. So now, given manager 2, you can find all of his subordinates all the way till the last engineer. So manager 2 has, so now we can go here, subordinates of manager 2. So you see that manager 2 has lead 3 and lead 4, and then it's funny here, lead 3 and lead 4 don't have any engineers reporting to them. Here lead 3 and lead 4, 6, 7, there are no engineers reporting to 6 and 7. So his subordinate list stops with lead 3 and lead 4. That's it. So yeah, for these superiors, it goes till the last, right? Till the boss's report ready, that is null. But here there is nothing like that because it goes as low as possible. So you can't guarantee it goes till here. So you can see that it goes till 3, but that is the lowest. I mean, in terms of the role. I'm probably confusing that part. Ignore that. I hope you understood what I said. And then here's the fun part. I keep saying everything is fun, right? I am bad at podcasting. How will I be like Joe Rogan? Let's see. It takes time. Okay, so then we have top 10 employees with ratio of salary, and then uh, top 10 employees with ratio of salary. See, people who are listening to this right now, don't make a judgment. This is a disclaimer. I mean, not disclaimer. This is like, what is that? Non sequitur. So what I mean is, the way that I am fumbling to explain these things, don't make any judgment out of that. A conversation, a conversation is a dialogue. At least it is a dialogue. A minimum, there should be two people talking to each other. Only then the conversation will flow. You ask something, I say something. I ask something, you say something. So there is a flow to it. If I am the one talking and I'm just talking to a screaming Mac, there's no conversation going on here. It is just my mind coming up with all sorts of thoughts, and then there is this judgment, and then there is this, I don't know, the hunger. All of these things are factoring in. So I'm doing a very pretty bad job of communicating my words, my thoughts. So I hope to improve on this. But so far, don't judge me. That's what I request. If you judge me, fuck you. Okay. So this is the next thing. Top 10 employees with ratio of salary. Say for example, you list all the top 10 employees in a company, and then you want to see like how, even though it says top 10, the first guy, the first guy salary can vary vastly from the second guy's salary. So it is best to know the percentage among those 10 guys. So that is the aim of this question. So the result would be something like this thing. So there are 12 employees, but then we are only bothered about top 10 salary. So we get only 10 results, and sorted by the decreasing order of salary, 120, 40, 30, 10, like that. And then if you add up all of these salaries, you get 350, and then you can just find a percentage like 120 by 350, and then you make it as a percentage, and then you get 34 percentage. So you can see that in this top 10 list itself, the boss's salary is like 34 percentage, and compare it to the manager's salary, that is just 11 percentage, and then you go all the way to the engineer, you see only it is 2.8 percentage. That is disparity, people. That is disparity. Okay, so that is what we want to build. So how are you going to do that? First you need the total of this thing, and then this division is just a simple thing, but the tricky thing is, let's go and see what the tricky thing is. um, Seems to me that it's not that easy to get the sum of salary of top 10 employees sorted by this thing. So I found two ways. For a moment, just ignore this query, and let us consider the only problem that we are going to focus now is to find the total sum of salaries of top 10 people. How would you do that? I spent quite some time on this thing actually. I thought it was easy, and then I was like fucking around. I thought of doing it in a single query, but then apparently it couldn't be done in a single query, it seems. You have to write a subquery. So the simplest and most easy to comprehend method seems to be this. So select sum of salary from, take the record from another inner query. Select salary from employee. So here is where you get the ordered list. I mean order by salary and the top 10 by salary, and then among that you do the sum. So why you can't do it right away? Why can't you do select sum of salary from employees order by this thing? The reason is it would total all of the 12 employees, not just the 10, because the order by and limit will apply after the aggregation. So the order of the SQL query is very important there. So that is why you can't do it in a single query. So that is why you have to run it as a separate thing, separate query, get the 10 records, and then run the aggregate query on that. So that's why. And what is this T? So when you're going to uh, run a query on this temporary data set, you need to give it a table name. So the T is a general convention, so you can give anything, or maybe something like top 10 something, or top 10 employees would be good. And then there is this another way, the same query written using my favorite method, that is the CTE. It is just the same thing. So this inner query, I'm taking it as a with expression, with CT expression. So I'm just saving it in a temporary table called top 10. So I mean, I'm not doing it. The database engine saves it as top 10, with top 10 as the top 10 employees. And then we are just querying this top 10 table for the sum of the salary, their salary. That's it. And then you get the same results. So you can, let's run it and see. See, you get 350, the same 350 here and here, right? So these are the ways that you get the salaries of top 10 people, and that is what we're going to need it. So that is the reason I'm using that is the reason I have to use two CTEs here actually. So this query looks complicated because it has two CTEs. One is this one, top 10, and then another is top 10 sum. But uh, it is just a way to get the salary sum value. So it is easy. So as explained in these two queries, you first get the top 10 employees and save it as top 10, and then use that top 10 here, and then get the top 10 sum value here, sum of it, and then use that top 10 sum in the last query, in the final query, to calculate the percentage. So the percentage that you have to calculate is slash. So you give the ID name. So this is how it looks, right? The data set. If you go here, salary, percentage, and total. So you have salary and this entire thing till this thing percentage, and then this guy total. So I hope you understand this part, where you give a column name and then this is the same as this thing, as. So you can represent in the output column name as a different name, and I came to know that this as is redundant, so you don't have to give it. So I like not giving it and just typing it in a space, and so without comma. So it is just an alias for that column that is going to be printed here. So you can see it here that it prints as total, and this thing prints as percentage, total, and then percentage. Okay, so how is this percentage calculated? What is the formula for percentage? Divided by the total sum, top 10 sum, which we have it here, and then the salary into account, which we have it in this same table. So either salary into 100, and since this will come in floating point numbers, you need to typecast it to the numeric, the topmost level of the data type in postgresql. I think it encompasses both integer and float, so it is best to go with numeric. So once you typecast just the numerator, you don't have to do it for the denominator, you would get the result in accurate float point, I guess. So this is what you see here. Okay, so that's it. Yeah, and then the last use case. This is another interesting use case. Uh, what the problem statement said is, like, you should also support like the use case where an employee resigns. So he can be anybody in the hierarchy. So he can be let us assume it is not boss. Okay, so it can be a manager or a lead or an employee. So if it is a manager who is resigning, so he is in the tree, he is in the middle. So when he is removed, like people at the top and top to him and bottom of him are affected, right? So the requirement is, let us say for example we have this guy A. We have A as a manager, and X and Y both report to A, and then A in turn reports to B. Now A has decided to leave the company. So now what would happen to X and Y's reporters? So we have to uh, make them point directly to P. That's it. X and Y report to A, who report to B initially, and then A decides to resign. And then what we have to do is make X and Y report to A's boss. So directly B. That's it. So how would you go about doing it? First take A's reporter ID and then assign to reporter IDs of A's reportees. That's it. So this can't be done in a single query. First you can update it in a single query, but you need to delete it in the next query only. Don't complicate things by putting too many commentable expressions in a query. So each CT should have a purpose that can be stated easily. So here the purpose is we are just updating. First we are so before deleting A, first we are updating A's reportee's reporter ID with that of his reporter ID. That's it. This line we are trying to do here in this CTE. And then after this query is executed, so now A is kind of like not dependent on anything. Nobody is dependent on him. So now it is safe to delete A. That is what we are doing. So what we are doing it is first getting the guy A, the manager, whoever is decided to leave. So we are taking him in a CT as resigning. So he is the one who is going to resign. And then what we do is we just update employees. What we do is we take employees whose reporter IDs are resignees ID. So who are all the guys who report to him, and then we just update their reporter ID to resignee's reporter ID, his reporter ID. That is this guy B. That's it. And then we can delete this A. That is delete from employees by this thing. Now if you run and see what you see, so we are deleting lead to Joe, right? So what happened? This is the initial data set. Let's go back to initial data set. So lead to Joe. So his ID is 5. Who are all reporting to 5? Okay, 11 and 12. So 11 and 12 are reporting to 5. So what would happen if lead 2 goes? Now for this guy engineer 4 and engineer 5 should not report to 5 anymore. So they should report instead to 5's boss. There is 2. So here it should be 2 now. So they report to manager 1 now. So let's see, that is what it happens. So now after deleting, you can see that now instead of the 12 rows, we now have only 11 rows. We did select star, but still we only get 11 rows because we deleted lead 2 Joe. See, after lead 1, it is lead 3. Lead 2 is not there. So now engineer 5, who previously reported to lead 2 Joe, are now reporting to manager 1. That is lead 2's manager reporter. Got it? So in the next video I would, so now as you can see that it is now very clear the database structure of the application that it is going to take and the queries that you're going to do, and it's kind of like clear. Now you can design a dumb application, can be centered on Rails around this thing, and you don't have to rely on Rails provided validations. They all actually cause a lot of database queries, and so yeah, just know that, and I will see you in the next video.